Okay, we're going to look at systems of inequalities, and we're going to do solving today. So find this page. You may need to pause the video and find this page in your notes. Okay, so let's go down here to the bottom. So we're going to solve systems of equations by substitution. So system equation, you're going to solve for one variable, substitute equation into the second, and solve, substitute in the first equation, and solve, check your solution. Okay, so let's look at this problem here. So first of all, if I wanted to solve by substitution, I need to solve for x or y. So if I'm looking at this one here and I wanted to solve for x or y, x would be easier. So I have x minus y equals 3. I can add y to both sides, and I get x equals y plus 3. So I solved the first equation for x. I'm going to take that value and I'm going to substitute it into the second equation and solve in place of x. So in place of x, I'm going to put y plus 3. So I'm going to have y plus 3 and then plus y equals 7. I'm going to combine like terms, so that's going to give me 2y plus 3 equals 7. Subtract 3 from both sides, because I'm solving for y. 7 minus 3 is 4. Divide by 2, so y equals 2. Remember, when we have a system of equations, we need an ordered pair for our answer. So this is my y. Now I need to solve for x. So I can take this, plug it back in, and substitute it back into this equation. So 2 plus 3 equals 5. So that's what x equals. So my answer to this is 5, 2. Okay, so if we look at Desmos, let's clear these, and we put that function in here. I'm going to show you how to check it with Desmos, and then I'm going to show you how to check it using the equations, okay? So we're going to take and we're going to do x minus y equals 3, and then x plus y equals 7. Okay, here's the answer, 5, 2. Remember, it's where the lines intersect. Okay, so there's our answer that we got there, 5, 2. If we wanted to check it using the equation, we would plug 5 in place of x, 2 in place of y. So in this first equation, we would have 5 minus 2 equals 3. Does x minus y equals 3? It checks out because 3 equals 3. So that's all great. This ordered pair could satisfy this equation, but not this one, because it could be a point on this line, but not this line. So you have to check it in both equations. So 5 plus 2 equals 7. It checks out. Okay? So let's go over here and look at this one. If I look here, the easiest thing to solve for would be y. Okay? So we could have negative 2x plus y equals negative 7. I'm going to add 2x to both sides. So y equals 2x minus 7. So I solved for y. So I'm going to take this and I'm going to put it in place of y in the second equation. So that gives me 4x minus 2, and I'm going to plug that. I'm going to substitute it in place of y. And then this is just an equation like we did in unit at the beginning of this unit. So we're going to distribute the 2. Okay, 4x minus 4x, that's 0. So I have 14 equals 14. Okay, does 14 equal 14? Yes. So that's a true statement. So that tells me that this is going to have infinitely many answers. Okay, so if you recall, when we were graphing, if you have infinitely many solutions or answers, then it means it is the same line. So if I graph these two functions, which I'm fixing to do in Desmos, it will create one line and not two. Now, if I had come up with like 0 equals 14, that's not true. So that would have been no solution. So be careful. If it comes out to be true, you get infinite solutions. Not true, no solutions. So let's go back to Desmos. Clear off the lines. And I do want you to practice using Desmos because you're going to be able to use this on your EOC. So you're going to have negative 2x plus y equals negative 7. And then 4x minus 2y equals 14. Notice that line, did you see that? When I put the 14, it jumped right on top. One line. Okay? So that's why we have infinitely many solutions, because this is an answer. If I went over here, this point's an answer. Every point on this line is an answer to the problem. Okay, so that is substitution. That is the method that most students do not choose to use. So we're going to look at the solving by elimination. So let's talk about how we solve by elimination. Okay, so when you solve by elimination, you're going to eliminate a variable. So you're going to line up the equation, multiply to get opposite coefficients. Remember, the coefficient is the number in front of the variable. Add to eliminate a variable and solve. Then we're going to substitute it back in to get the other variable and then check the equations. All right, so here, if you notice, positive 5y, negative 5y. We do not need to multiply in this equation because they're already opposite coefficients. And when I add these two equations together, I'm going to get 0y. So 1 plus 2 is 3x. These will cancel. And then 21 plus 12 is 33. So we eliminated the y by adding them together. So that's the reason it's elimination. Then we're going to divide both sides by 3, so x equals 11. Okay, so this is not our solution because we still have systems of equations and we still need an ordered pair. So we have x, now we need y. So we can take this x and plug it back into either equation and solve for y. So I'm going to plug it back into the first, so I'm going to have 11 plus 5y equals 21. Now I'm just going to solve for y, so I'm going to subtract 11. 5y equals 10. Divide by 5. So y equals 2. So my ordered pair is 11, 2. Now if we go back up here, 11 plus 5 times 2 is 10. 11 plus 10 is 21. So it checks in that one. 2 times 11 is 22, minus 5 times 2 is 10 again, so 22 minus 10 is 12. So it has to check in both functions in order for it to be the solution where they intersect. So if we go over to Desmos, we're going to do one more. Now don't just go to Desmos for your answers, because on your test, I'm going to need to see you work these out on a couple of problems. So make sure you know how to work these out. Okay, so we're going to put that in there. Okay, so let's put our functions in here. So we have 3x plus 5y equals 21, and then 2x minus 5y equals 12. We go over here, 11, 2 is where those two lines intersect. So that is what we got when we solved that. So again, make sure you know how to solve them mathematically, and then you can check it using your Desmos. Okay, so here, solve by elimination, and here we're going to look at problem number 2 here. So I can't get rid of x, I can't get rid of y, because neither one of them have the same coefficient with opposite signs. Okay, so if I looked at this, which one would be easiest to get rid of? And that would be y. I could multiply the bottom function by a 2 to make the coefficients the same, but I need them to have opposite sides, so I'm going to multiply by negative 2. Okay, so I'm going to write the first one down because I didn't do anything to the first one. Now, if you remember the rule The number one rule of solving an equation is whatever you do to one side of the equation, you have to do to the other. So if I'm multiplying this negative 2 times this y, I have to do it to the whole equation. So negative 2 times 2 is negative 4x. Negative 2 times negative y is positive 2y. So see, same coefficient, opposite signs. Negative 2 times 8 is negative 16. So don't forget to distribute that 2 across all the equations. All right, now we can add them together. Negative 3 minus 4 is negative 1x. That's 0. 4 minus 16 is negative 12. I can divide by negative 1, and x equals 12. Okay, so now I can take this, plug it back into either equation in place of x. So I'm going to just do it in the first one. 3 times 12 minus 2y equals 4. 3 times 12 is 36. Minus 2y equals 4. Pause the video if it's going too fast and think about it. So then I'm going to subtract 36 from both sides. I get negative 2y equals negative 32. Divide by negative 2. So y equals positive 16. So my answer here is an ordered pair, 12, 16. So let's go to Desmos one more time. Check our answer in Desmos, and then hopefully you're going to understand Desmos and you'll get used to using it to check your work. Remember, this is not the way to do your work. It is a way to check. 12, 16. So a common mistake is for you to put 16, 12. So remember, it's always x, y. Okay? All right, so let's go and look at one more problem together here, and then we'll let you practice some. So we have 10 minus 4y equals negative 13, negative 10 plus 4y equals. So here I can eliminate the x's because they're opposite signs. Oh, and I can eliminate the y's. So that's going to give me 0. Negative 13 plus 10 is negative 3. Does 0 equal negative 3? No. So this is no solution. This means that when I graph these, and I'm going to do it for you because we want to see these, they're going to be parallel lines. If not, I know I did something wrong. All right, so we're going to go back to Desmos one more time. And we got 10x minus 4y equals negative 13. And then negative 10x plus 4y equals 10. And then there we have that. Let's zoom. Got to zoom really. Let me go home. Okay. So remember, if you're zoomed out, it's going to look like it's the same line. But when I go home, because these are really close together, you can see they're parallel lines. So I wanted to show you that and to make sure. Be careful where you're zooming and stuff because they can appear one way when they're really not. Okay, guys. Check your plan book. We'll practice today and some more tomorrow, and then we will see what questions you have.